Right, so this video is going to serve as a quick review for the Pythagorean theorem test and functions test that's on Monday, tomorrow. So first part is going to be Pythagorean theorem. So I'm just going to write that in. So Pythagorean theorem. So first thing you need to be able to do is to identify each side of a right triangle. So remember the formula for Pythagorean theorem is a squared plus b squared equals c squared. Now this does not have to be memorized. You are going to be provided this on STAR and on the test. So you don't have to memorize this formula, but you do need to know how to use it, how to solve for it, and know how to identify your A, B, and C variables. So numbers are going to go into these, and we're either going to solve for one or confirm whether or not we're dealing with the right triangle. All right, so look at these triangles up here, these right triangles. You want to be able to identify where the 90-degree angle is. So remember, 90-degree angle makes a perfect L shape. So 90-degree, L. So that's an L. Sometimes it'll be like that. Sometimes it'll be sideways like that. So you have to be able to identify those two side lengths, and that's going to be your A and B. So your A and B are going to be the legs, which make up the 90-degree angle. So to identify that, you look for the L. So here's the L right here. So that means this side right here and this side right here. So here's our 90-degree angle. So that means this side and this side make up A and B. And it doesn't matter what order you put those in. This could be B, this could be A. What does matter though is your C variable, your hypotenuse. So your hypotenuse is always the C variable, and it's always opposite from the 90-degree angle. So the side length C does not touch or make up the 90 degree. It's opposite from the 90-degree angle. So always keep that in mind. A and B, your A and B variable make the L shape, and your hypotenuse, the C variable, what you plug in for C, remember is on the right side of the equal sign, is always opposite from your angle, right angle. All right, so let's take a look at solving. So right here, first we need to identify A, B, and C. So first we need to find our 90-degree angle or where our L shape is. So there's our L, so that's our 90 degree. So that means this side and this side make up our A and B. So that means our C has to be the other side, opposite from the 90-degree angle. Great. So now we know we're solving for C. So if we have A squared plus B squared equals C squared, which is our standard formula, we are looking for C squared. So I'm going to rewrite the equation, C squared, the variable we're looking for, and I'm going to plug in for A and plug in for B. So A we identified as 9. It's going to be 9 squared plus B, which is 4 squared. So we get 9 times 9, which is 81, plus 16 is equal to C squared. Let me get my calculator handy. All right, so just to confirm, 81 plus 16, I'm a double checker. All right, so 97 is equal to C squared. So our goal, remember, when it comes to solving equations is to isolate the C, get C on its own. Inverse operation, getting rid of the square, is taking the root. So C is going to equal whatever root 97 is. And that's just a matter of typing it in on the calculator. Remember, the typing the root symbol is Control X squared, so that yellow button, then X squared. So 97. Y'all can probably hear the dog barking in the background. So 9.8. So C equals 9.8. So that means our C variable, so if we need a length of this part right here, it's 9.8. All right, and then on the other part, so our 90-degree angle is given to us. So that means we have these two sides. So we got A, B, and our hypotenuse this time is given to us. So when we're plugging in A squared plus B squared equals C squared, C this time is given to us. So we have 11 squared, plug in for A, 5 squared, plus, and then B squared is what we're looking for. So rewrite that. We got 25 plus b squared is equal to 11 squared, which is 121, minus 25, minus 25. So this is just a matter of solving equations. And that cancels out. Bring down the b squared. So 121 minus 25 is equal to 96. Get b by itself. Take the root. So b equals whatever root 96 is, which is 9.8. Oh, same thing. So that's how you set it up to solve for either the leg or for the hypotenuse. So remember, whenever you're looking for one of the side lengths, you're always going to subtract the square of this minus the square of this, and then take the root of it. And over here, think of it as you're always going to add the square of these two numbers, and then square root, find the root of these two added together to find the length of C. So that's in a nutshell of what you're doing. All right, what you also need to know is when it comes to rectangles, you need to know that rectangles, so this side, this side, this side, and this side are perfect 90-degree angles. And when they say something about cutting diagonally, so diagonal sidewalk in this example, so the way it's visually going to look like, so always draw out a picture, that's where your diagonal is going to be. So if you did it like this, then your diagonal would be like that. All right, notice that they tell us it has dimensions of 12 by 25. So this is the rectangle. Make sure you're paying attention to what it's telling you. So the rectangle has dimensions of 12 by 25. All right, so 12 by 25. So remember, we have length and width when it comes to a rectangle. So your length is always going to be the longest part, and then the width is going to be the shortest part. And those are the two sides. So that means this side's 25 and this side is 12. So if this side is 25, that means this side also has to be 25. And if this side is 12, that means this side also has to be 12. Okay, so they tell us the next project is to construct a diagonal sidewalk. So this diagonal right here is the sidewalk. Remember what I said about the word diagonal or diagonally? Whatever number is associated with that word diagonally, it is the C variable. So always remember that, because diagonal is always slanted like that, so that's going to be your C variable. And then the length and the width are going to be your A and your B. So always keep that in mind. Okay, and then from here, so if it's asking for the diagonal length, you'll use Pythagorean theorem, just like on the other problems. That's the same formula you'll use. So I just want to go over that concept. Just remember that diagonally is you're looking for the C variable. Or if a number is already associated with diagonally, the word diagonally, then you're given your C variable. Like in this one, the diagonal length is 16 feet. So if we were to draw a piece of paper, or not piece of paper, they're telling us just rectangle. Okay, so the length is 14, length is the longest part, and then it's asking what the width is. So width, we're going to put width, and the diagonal length, we're talking about the inside of the rectangle, is 16. So the word diagonal is associated with 16. So that means C equals 16. So that means when you're setting up your variables, A, B, and C variables, that's how it's going to look like. So W becomes an A. Think of it that way. So A, B, and C whenever you're using Pythagorean theorem. So this would be set up as, we're looking for the width, A, plus 14 squared is equal to 16 squared. And you will solve just like we did on the first page. All right, this one's asking, so remember, whenever you're giving a set of three numbers, you're going to assume that they are the side lengths of a right triangle. So they're telling us that 5 squared plus 12 squared equals 13 squared. So the way that we confirm that is, remember, the formula for a right triangle, or for Pythagorean theorem, is a squared plus b squared equals c squared. Key here, equal to. So that means this squared plus this squared has to equal this squared for it to be a right triangle. So in order to confirm that, we're going to say 5 squared plus 12 squared is equal to 13 squared. So we need to confirm whether or not that's true. So 5 times 5, or 5 squared, is 25. 12 squared is 144. And 13 squared is 169. So we're going to add this up, 25 plus 144. That equals 169. So 169 is equal to 169. That's a true statement. So that means, because 169 is the same as 169. So that means the set of three numbers right here is a right triangle. So the answer would be, oh, okay, yes, this is a right triangle. And yes, we could use Pythagorean theorem. Let's double check this one. So 13 squared plus 15 squared equals 19 squared. One thing I forgot to mention is that usually the last number expressed is the hypotenuse, but remember the hypotenuse is always the largest number of the set of three. So 19, 13 would be the hypotenuse, which is the c variable, which goes on the right side of the equation. Okay, so 13 squared is 169, 15 squared is 225, 19 squared is 361. All right, so we need to confirm whether or not 169 plus 225 equals 361. So 169 plus 225 equals 394. So it's telling us that 394 is equal to 361. So this number is not the same as this number, so that is not a true statement. So this set of three numbers would be no, not a right triangle. So that would be how you would do that. Okay, so finding the hypotenuse or the c variable, so finding the distance. So they're going to ask you, what is the distance between this coordinate point and this coordinate point? On the test, I think they're already plotted for you. So 0, 6, so 0, 1, 2, 3, 4, 5, 6. And then 5, 0, 1, 2, 3, 4, 5. So whenever you're given a coordinate grid like this with a diagonal line like this, so remember this makes a diagonal, it's slanted, so you're looking for, you guessed it, the c variable. So that means you need to create your own right triangle. You can do it like this, or you can do it like this, just as long as your other two coordinate points make a square or a right triangle, and these are 90-degree angles. So just like the others, you're going to use a squared plus b squared equals c squared. Your a and b, so remember your a and b are always the two side lengths that make up the right angle. So that's a, that's b. So you're probably wondering, well, or if you don't remember, where do you get the numbers from, a and b? Well, you're counting how many units are from here to here, and then from here to here. So that means we're going to go 1, 2, 3, 4, 5, 6. So that's 6 units. So 6 squared. And then b, so from here it's 1, 2, 3, 4, 5. 5 squared equals c squared. And you will solve it just like you normally do for Pythagorean theorem. So that's how you do that. All right, on this next part here, I mainly just want you to understand the concept of Pythagorean theorem, what's happening. So, for example, so here's A, here's B, here's C. So those are your side lengths. You have your triangle. So remember we always say the square of A plus the square of B equals the square of C. So we need to understand that. So that means the square, so which is to the second power. So this whole thing right here, this whole square right here, is the side length of what that side of the triangle is squared, which makes this whole squared an area. So the area of this plus the area of B equals the area of C. And then conversely, you can find the root to find what the side length is. So make sure you understand the concept that, so here's a squared plus b squared equals c squared. So we're adding up this area plus this area, and it equals this area right here. So if this were units, for example, plus these units, this is just an example, the number of units here and the number of units here, which is the area, is going to equal the number of units in this square right here. So just understand the concept that square m plus the square of n, so this square plus this square equals the square right here. So understand that concept. All right, next is over to functions. So determining whether or not something's a function. Okay, first it's graphs. So remember, when it comes to graphs, you perform what's called a vertical line test. So remember, determining if something is a function, x values can't repeat. So if I were to do the vertical line test, remember, ignore the x-axis, which is this line right here, and ignore the y-axis. So we're just looking at what the line or what the image is. So this image is this image without the x and y axis. So if I were to draw a vertical line anywhere, it intersects between the given image one time. And if I do it over here, it's also one time. If I do it right down the middle, it's one time. So it only intersects one time. So that means, yes, we have a function. Remember, a fancy way to ask if something's a function is, does y represent a function of x? Does y represent a function of x? Remember, that's just a technical way to ask if a certain graph or a certain set of numbers or coordinate points is a function or not. All right, same thing over here. So we have a little sideways L. So if I were to do this and perform a vertical line test, how many times does it intersect? 1 and 2. 1 and 2. That's 2 times. So 2 or more times means that it's not a function. Because when x values repeat, that means there's 2 x values. X values repeat means it's not a function. All right, looking at this one over here, looks kind of wonky. So notice there's some space here in between, but same concept. So this is where it starts and it goes, and then it starts right here and goes. So same thing. One time. One time. One time. So this would be, yes, a function. Okay, so now we have a set of coordinate points. Remember, we're just looking at the x values. If x values repeat, meaning that if this number, and this number are expressed more than once, meaning that if there's double number or 3 numbers, 2 or more of the same number, then it's not a function. But if all of these numbers are different, then you have a function. So we have 3, -1, -5. Those are all 3 completely different numbers, so we have a function. That's your answer. All right, we have 9, 4, -1. All completely different answers. You have a function. -2, 3, -2. -2 is repeating and giving us an output of 1 and an output of -6. Can't have 2 outputs for the same input. So -2 is repeating, so that would be not a function. All right, and then the mapping. So remember, you're counting how many arrows are coming out of the x value. If one arrow comes out of each x value, then the whole thing's a function. If there's at least one number on the left side that has 2 arrows coming out of it, then it's not a function. So we got 1 arrow, 2 arrows right here with to 2 different numbers. So already we can say this one is not a function. Let's go here. 1 arrow, 1 arrow, 1 arrow. We have a function. 1 arrow, 1 arrow, 1 arrow. We have a function. So that's functions for you. So, and I do also want to go over coordinate points. So if these were as coordinate points, so like 2, 6, just in a different form, 3, 7, and 4, 8. Same thing. You're just looking at the left number. We got 2, 3, and 4. Those are completely different numbers. Well, don't pay attention to this because that's technically 3, 6, 3, 7. So not entirely the best example. But if I was just given these coordinate points, then it would be a function. So over here it would be 3, 6, and 3, 7. So this one also expresses 3, 6. So in this case, 3's repeat. So that would be not a function. Sorry about that. Okay, so it's not a function because there's 2 different x's. However, this one's a function at the bottom because there's 2 completely different numbers and they're going to completely different y values. So the relationship represents y as a function of x because each value of x is associated with a single value of y. So remember, x repeating, no function. So if it tells you a reason like the relationship is a function because it's associated with 2 values of x. So remember, if you see something like 2 values of x, when you have a word problem, that is not a function. That's not the reason why it's not a function, because two values of x means that it's not a function. So that is the review for the test tomorrow. Just understand those key concepts and you should be successful.